Hey friends, I'm Ash Leatherwood, your friendly neighborhood apologist, and today with us is a very special guest. With us is my friend Dr. Perry Sherman. He has a background in apologetics and law. He has a degree in engineering. He has a patent on the stealth bomber, and he has a PhD in psychology. Now, I'm really excited for a conversation today because we're going to be talking about evolution, intelligent design, and most specifically, information theory, which is something that I'm really interested in. So I'm stoked for our discussion today. Thanks for joining me, Perry.
You're welcome. Love it.
Yeah.
Thanks for
So,
having me.
yeah, I'm really excited for our discussion. So, to set the groundwork of what we're going to be talking about, can you kind of explain what exactly is evolution?
Yeah, it's a good question because people throw around different terms, macroevolution, microevolution, and they're really completely different things. So when you're trying to evaluate something scientifically, you really have to define what are your operational variables and what are you talking about. So I like to define, I got this from Dr. A.E. Wilder Smith years ago. He gave an equation. So evolution would be the equation matter plus time plus energy will give you life, equals life. So if you have enough matter and you have enough time and you have enough energy, eventually you're going to get life out. That's what I define as the evolution equation. And so microevolution isn't really talking much about that. It's like, can things adapt? Can species shift from one population being more predominant to another? And it gets murky. So I'm really talking about what would be called macroevolution. Can life come from just matter, time, and energy? If you got enough of it, you're going to get life out. So that's the definition that I use for evolution.
All right, that's great, just to kind of set the groundwork. What about creation? How can we define creation?
Yeah, so that's a great question too. Creation I define as matter plus the I factor, or what is called information, concept, idea, organization. But let's just call it information. If you add information to matter, then you get life out. That's the creation formula. And it doesn't matter who is adding the information. If you had a very intelligent scientist, and he added information, organized the matter, he could make a life form, but he has to add information. And so that begs the question, what is information?
Mm.
And really, actually, to get life out, you don't need necessarily a long time or a whole bunch of energy, as long as you have the information. So, information, what is information? That was the next question, right?
Yeah, you got it.
So
Yeah.
information is distinct from, we live in a world full of information. And what's the difference between information and noise? And how do you separate it out? Satellites that go out into outer space to explore planets and the like, they have radio waves they're sending back, but the noise and the static that's coming from around us in the universe has to be separated out from the distinct information that the satellite is sending back or the spacecraft is sending back. So there's a whole science of information. It was started by mathematicians and very prominent mathematicians named Shannon and Wiener. And so they defined what information is. And information is, by definition, something that is not determined or produced by natural law. Otherwise, it would just be noise. And distinguishing information is something that is then a surprise effect. It's a surprise to natural law. So, for example, there are telescopes looking out into deep space, looking for intelligent life. We have telescopes around the world. Carl Sagan, a very famous atheist, and had a program a number of years ago. Many of you are probably too young for it, called Cosmos. But he was very interested in finding intelligent life maybe in the universe. And how would you know when you got a signal from an intelligent life form versus just radio waves, static radio waves?
Mm.
Any idea?
Hmm. Kind of going off what you said would be something like having to do with that surprise factor, something that cannot be produced by natural law alone.
Right.
Yeah.
Something can't be produced by natural law. So, for example, if you had static, you have radio waves, uh, it's not coming from an intelligent
Hmm.
life form or intelligent source. But if they had a signal coming at one point to these radio telescopes, and it was repeatable pattern. It was beep, 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 and they got very excited. Maybe we have a signal, but then they determined that this was a rotating pulsar. So a star that's rotating would have a repeatable pattern, but it would just be because the star is rotating. If they got something, however, like beep, 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 beep,
Hmm.
then it's a surprise. That is something that is not produced just by natural law because it has a pattern in it that's distinct. And so Shannon and Weaver defined information. The smallest level of information is a surprise effect. And you can add all kinds of surprise effects. And what we're doing right now is we're communicating to each other, and our computers are collecting information from the source. I'm talking to Ash. Ash is talking to me. It's sent over thousands of miles. Well, the computer is distinguishing what is the difference between just random and actual signal. So in our computer language, we have two symbols. I just gave maybe the Morse code with dots and dashes, but computer language has two, zeros and ones, and everything can be described in zeros and ones. And if it's random, then it's meaningless, and it's not a surprise effect. But if it is ordered, it is a surprise effect. So anyway, that's the difference. Surprise effects.
Cool. I love that explanation of it. Surprise effect. That's going to stick with me. So, talking through information, it doesn't sound like we're talking about a material thing. Is information non-material? And if that's the case, how can that be? What does that look like?
Yes. So the information that's coming from me to Ash or coming from Ash to you is not dependent upon the material that carries it. So, for example, I'm looking at a camera and a computer screen, and my computer is maybe storing it on a magnetic disk drive. And the magnetic disk drive is translating the material, the information into uh, an optical signal, which is completely different than a magnetic disk drive. Fiber optics is sending the information. At some point, the information is being sent from his wireless into radio waves in the air. Completely different. Again, radio waves are completely different from the photon waves that are in the fiber optic cable. And maybe you're hearing it in a completely different form, which is you're listening to it, the sound waves, the patterns of the sound waves are carrying the information to your ear. So these are all completely different. But the information is the same. So the information is not material. It's not dependent upon the material world, but it can ride on the material world. And the transmission of the information is governed by natural law, but the information itself is a surprise to it.
Okay, yeah, that makes sense. That information is not reducible to the media that is used to transfer it. Like the information in, say, one of my books over there, it's more than just paper and ink. The information itself is carried through the paper and ink, but it's not reducible to actual paper and ink itself. So that just transmits it. So information itself is a non-material thing, which makes a lot of sense. Okay, cool. Now you kind of defined what information is. Where do we find that in the real world? Say broadly in the universe. Where do we find this kind of information in the universe? And where do we find this information maybe more specifically in life?
We find information all over the place. So information is actually in the atoms themselves. So if you take an atom and you blow it up and you take a very tiny amount of mass and it converts into energy like in an atomic bomb, energy equals mass times the speed of light squared. An enormous amount of energy comes out and it gets dispersed and it's gone. Try getting that energy back into the atom. That's really tough. But in the natural world, things go where the organization of the energy is into the atom. It's mathematical formula. It's a structure. And there is information in every atom. So in the universe, there's tons of information. It's energy contained in or defined by mathematical formula.
Hmm.
And once we blow it up, the amount of information or the order goes down. It gets dispersed. And that's naturally what happens. So it's all over in the universe. We have information all over in the universe.
Wow, that is incredible. It's just mind-blowing to think about all that information in the universe and within life. Now, to this point, we've been talking about information, and honestly, there's probably not many people that disagree with you, even given different worldviews. As we kind of push along to now start trying to talk about where this information comes from, where people might start to have different opinions on it, I just want to ask you, what scientific questions are we really asking?
So we're asking this question, where does information come from? And that's a scientific question. And I actually don't need to, in the beginning of the question, postulate it comes from God, but it has to come from somewhere, and it doesn't come from the matter itself. And when we see information arising, we always see it. And science is, by the way, is simply observation, human observation plus logic. Observation and understanding what we're observing, putting it together and thinking about it. So there's nothing strange about where you go as long as you're making observations and you're thinking about it logically. So if I see a pattern, such as Carl Sagan, if he saw ... dash 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 ... in a radio telescope, he would know that it came from an intelligent source, and that's what he's looking for. And that's the point, is information always comes, and everybody knows it, always comes from an intelligent source. And even we can see that scientifically. We see all kinds of information, and it's always being developed by intelligent sources, creative minds and people. We can see that.
Yeah.
But what about the information in the entire universe? Where did the information come from?
Okay, cool. That makes sense. I think you're right that when we look around at the information that we see around us, the kind of information we come in contact with on the daily basis, it flows naturally. We all conclude that it came from intelligence. But a question that someone might ask is, what about some sources of information in nature, such as in crystals or snowflakes, where they do get more complex as the result of natural law? Is this information coming from natural law? What would you say to that?
That's an excellent question. And I know the famous physicist Lawrence Krauss was talking to Ray Comfort. Ray Comfort got to ask him 3 questions. And when he asked him about the source of information, this is what Lawrence Krauss brought up. He said, well, spontaneously, water forms ice crystals, and all these different designs, infinite number of designs of ice crystals. So there's a natural process producing order. Well, what he didn't recognize is that the order that is, it's actually not produced, it's manifested by the water molecule. So the water molecule is triangular, and its structure is such, 2 hydrogens and an oxygen, is such that when it combines with and freezes and forms a solid, there's only a specific way it can combine. So the degrees of freedom, when we talk about in statistics, degrees of freedom, there's only a certain limited number of degrees of freedom. So you never find a snowflake with 5 sides. You never find a snowflake with 8 sides, or 10 sides, or 7 sides. You only find all snowflakes have 6 sides. And why is that? It's because the information that is being expressed is already in the water molecule. So there's any number of infinite designs that could be randomly come out of the freezing of a water molecule, but they're all going to have 6 sides. And so the information is there. It's there in the water molecule. Now, if you take the water molecule and you blow it up and you get just energy out and you have no mass left, then you're never going to get any snowflakes because you've just dispersed the information. But the information is already there and it's simply being expressed. By the way, it's the same way with life. The information is on the genetic code, and the code in your DNA defines, it delimits the degrees of freedom that can be expressed. But the information is there, and you express the information. Now, if you work out, your information is going to be expressed. You're going to get stronger, bigger muscles. And if you use your hands regularly for physical work, your hands are going to develop calluses. But that information is already there in the DNA, and it's just being expressed as it interacts with the environment.
Okay, that makes a lot of sense. Now, how about this? Let's say that one of our viewers is from a materialistic, naturalist worldview. How might they explain where this information comes from? How can they make that a reasonable position? What might they say? What might they appeal to?
Well, when I've asked people that question, where does the information come from? I've really not had anyone give a source. And even Carl Sagan has said, I've seen him on video talking about how when the Big Bang happened and all these atoms and all this matter got dispersed throughout the universe had to have more information and be much more organized before it exploded. And then the information decreased in the explosion, but it wasn't completely eliminated. So he believes the information was there at the beginning, but it begs the question, where does the information come from? And so some people have postulated that there's multiverses and somehow information is being injected into the universe from other multiverses. But that just begs the question, where did the information come from in the multiverse? Some scientists have suggested, evolutionary scientists have suggested that, the life on the Earth was seeded from alien beings that sent spores or some kind of genetic material to the Earth. But then that still just begs the question, well, where did the information come from in the first place?
Okay, that makes sense because they're just pushing it back a step, given these explanations. How about this one? According to natural laws, without intelligence injecting ideas, what actually happens to information in the real world?
That's a great question. So we go back to the equation for evolution, matter plus enough time and enough energy, and you get life out. Actually, the laws of thermodynamics are premier laws in science. They govern every chemical reaction and every physical reaction. And the second law of thermodynamics says that as time goes on, the order decreases. They call disorder entropy. And actually, it's kind of confusing because entropy increases. But what it means is the order is decreasing. And so with time, that's what happens naturally. And actually, time is the enemy of information. So if you have, supposing you have a picture of myself on a piece of paper, and you put it on a copy machine and you make a copy of it. And then you take that off the copy machine and you put it on again and you make another copy. And you take that copy of the copy and make another copy, and a copy of the copy to copy, make another copy. Eventually, if you do that many times, maybe 1,000 times, what are you going to have? You're going to have a degraded picture. And so we know that if we copy a picture and we downsize it to smaller amount of information, you have a gigabyte picture and you downsize it to, say 10 kilobytes, well, you're going to have a much grainier picture. It's not going to be as clear. It's not going to have as much information. Over time, as you continue to copy information, it actually degrades. And eventually, it will disappear and you will simply have equilibrium. And that's what the second law of thermodynamics says, is that time is actually the enemy of information. It's not the friend. It's not going to produce information. It will, by natural processes, degrade the information that's there. And so that's why we see a lot of problems in our genetic code. We have genetic diseases that have been caused by somebody in our past. Some ancestor had a mutation and then it got combined with other people. And so we have these things in our genetic code that we know don't work right. They disrupt how our bodies are supposed to work. And that's a degradation of the information that's there. It's not increasing information, and that's what naturally happens with time. So time is the enemy of information. And by the way, energy is also the enemy of information. That's the third law of thermodynamics. As you take a crystal and you cool it down to the lowest temperature possible, absolute zero, I think it's minus 273 degrees Kelvin, you will get the most ordered crystal, because as it heats up, the molecules are moving around and more disordered. But as you go to absolute zero, you get the highest amount of order. So actually adding information tends to decrease the amount of information. So energy and time are both the enemies of information. So this evolution equation is completely contrary to the laws of nature. That's not how things work. They go the other direction with time and with energy.
Yeah, that's so interesting. And it's ironic because in Darwinism, like the explanation given is, oh, you have enough time and obviously energy, it'll happen at some point. It'll happen over time. It's inevitable that we get this kind of mutation, this change, this evolution. But we see that, like you've been explaining, given more time and energy, you're just gonna get more degradation. Like it's even less likely to happen because there's gonna be more time for disorder to occur, not more ordering. So yeah, that's really interesting. Now, how about this? How about someone, maybe one of our viewers, that holds to our Darwinian perspective on the origin and succession of life? Now, given what you've been saying, now evolution starts to not make much sense at all. And it seems that they're pushed into a corner that it has to have occurred in a very short amount of time, not a long amount of time, for this order to actually work. What can they kind of do with that? Are they stuck in that corner?
Yes, and then still the problem is, where does the information come from? And information is not natural law, is not produced by natural law. It's a surprise to natural law. And that's how we recognize it is information. So how are they going to explain that? They have a very difficult time explaining that.
Yeah.
The Bible is actually matches what we are talking about. What does God create first?
Light.
He creates light. He creates energy first. And then he organizes the energy into mathematical formula, into atoms, into structures, into everything that we see. But the light is created first, and then everything, the light and the energy is all organized. And in God's mind, he takes ideas and information and he imposes it onto the energy, and that's how he creates the matter. Now, it's very interesting. You can go the other way. You can blow up the matter and you get pure energy out. And then, like I said, good luck getting it back into an atom, right? That's really hard to do, unless you're beyond time and somehow you can do it. But it's interesting, by the way, the first law of thermodynamics says that the amount of energy in the universe is always conserved. Energy can be translated, it can be transformed from one form to another. It can be transformed with potential energy to kinetic energy. For example, in the atom, it's potential energy in the mass. And when you explode the mass, you get all this kinetic energy out. But it's the same amount of energy. And energy is never increases or decreases. It's always constant, the same amount of energy. So since the very beginning of the universe, according to natural law, the amount of energy in the universe is the same now as it was then. It's just in different forms, and it's just been running downhill as far as it being useful and ordered for doing things with it. So the Bible is actually pretty accurate. We wouldn't know this until modern physics and modern chemistry and modern physical chemistry, that the amount of energy in the universe actually was created. And it hasn't changed since. And God ordered it. And then he took the matter and he added information. He ordered it to create life.
Yeah, that's so interesting. And on that subject, I want to ask you a quick question of something that I get asked all the time, so a misunderstanding that many people have. So energy obviously had a beginning, it was created, like you've been talking about. But many people think that contradicts the first law of thermodynamics, right? Energy is never created or destroyed within a closed system. So can you kind of unpack that a little bit?
Well, yes, in the universe that we live in now, just because it is ordered a certain way and it runs a certain way as we observe it now, it's not logical to believe that that is the only way things can operate, because God obviously did something very different. He says in the Bible, we don't see energy popping into existence now, unless some physicists might say, well, there's a multiverse and some energy is coming from another universe into ours from some other source, which is then to beg the question, where did that energy come from, right? But God says he made the energy in the first place, and that's very different. It's not the way the universe operates now is a constant amount of energy. We can't create it. We can't destroy it. It's a constant amount of energy. And that's the first law of thermodynamics from what we observe. But the energy had to come from someplace in the first place. And the Bible tells us that it came from God. He made it. And it certainly fits our scientific observations. It's constant now. But it came from someplace. And the Bible explains that God created the energy in the first place. Now we can't do that, but it is an explanation that makes sense and does fit the science.
Wow, yeah, that makes so much sense. To kind of top off what we've been talking about, to conclude kind of everything you've been walking us through, why does theism make the most sense of information and where it comes from?
Yeah, well, this is another question uh, that you can't actually know God or encounter him from just looking at the universe and just looking at the matter. You can know that he must be, or you don't even know if it's a he or she just looking at the universe. You just know that whoever this being is, he creates people with personality, so he's going to be greater than personality. He's at least personality.
Mm.
And you're going to know some things about him. He's awesome and amazing and incredibly creative, and can do things that we can't do and are amazing. So you've got some being that's personal, because you have personalities that are created, and is at least as complicated as the universe that he created. He's got to be more than, in order to create something that is that he's created. So you know certain things about him, but you don't really know who he is, and you can't know a lot more about him. That's why Romans 1 says everybody knows, just looking around them, that God exists, or a being exists that is amazing and awe-inspiring and spectacular. It's interesting because I see even programs on National Geographic or PBS, or they're talking about the universe as if it just evolved and there's no creator behind it, but they talk about it with such awe. It's really interesting how the awe-inspiring that the universe is, but they cut out why the awe is there, because the source of it is even more awesome than the universe. So you can't know that. But in order to know God, or know who or what created the information in the universe, he would have to reveal himself. And the Bible says that the God who created the universe did come into the universe. That's what Christmas is all about. is he cares about us, which is an amazing thing to think about, that he came into the universe and took on matter, took on flesh, and he came into our world in order to show us who he is and to invite us to have a relationship with him. Now, you can't tell that from just looking at the universe. You can just tell that, wow, whoever did this is incredibly awesome. But you can't tell specifically much about him. But the Bible says, and that's why I studied apologetics, is how can we know that Jesus actually really lived, that he really did the things that the Bible says he did? And that's a whole other topic. I love that topic, but that's a whole other topic. Did God actually reveal himself?
Yeah, I love that. Just seeing the wonder in the world around us, then also recognizing that ultimately we can't identify who this being is without him revealing himself to us, which obviously that's where Jesus comes in. God reveals himself to us so that we can know him, we can do life with him. So, yeah, I love that. So, we've gone through a lot, and at this point, I kind of just want to answer some commonly asked questions. So, lots of people ask, what about God and science? Someone might ask, that's all fine and good, but can one really talk about God and talk about science in the same conversation? Like, can we talk about God and this information? What's his place in this all?
Well, every major field of science was, if you look at who the fathers of physics, electromagnetism, astronomy, biology, disease transmission, even computer science, all these different fields, you look at who is pretty much the father and founder of them, you will find that they were all followers of Jesus. And they didn't have any problem with that. And in fact, probably the father of the scientific method, Francis Bacon, was a believer and a follower of Jesus, and he put together, here's how we're going to observe the world, and we're going to make deductions about the world, and he formulated that scientific method. And so it's not contradictory, or else you would have to say the fathers of every major scientific field that you benefit from was wrong. But actually, a belief that the universe makes sense and is ordered is inherent in every scientist who's observing it. The question is always asked. You find something, like you find some organelle in a cell, and you don't know what it does, but the assumption the scientists are always making is that it has some function, some purpose. It's there for a reason. I wonder what it does, and we're going to discover it. Now, when I was in my 20s, my older brother was studying medicine at McGill University, and they were teaching him, and he was telling me that some amazing percentage of the genetic code, 96% or something, was just residual junk DNA. Only the DNA that coded for proteins had information on it. And I said, really? I don't think that's correct. We are so incredibly complex. How do we repair things? How do we diagnose things in our body? I just got a cut on my finger, and my body, the information is there in my body to analyze what's wrong and to fix it, repair it. An amazing thing. There's information, there's so much information to run our bodies and to define our personalities, define all these things about us. It can't possibly just be coding for proteins. I said to my brother, it's like, that's crazy. There's so much information there, we don't even know what the information is. And now here it is, like about 35 years later, and they now know there's all kinds of information that they didn't realize what it does. And actually, there's probably more information than there is even in just the sequential DNA. There's probably layers of information on it. And even in the cell, there's information. If you take the DNA the genetic code, for example, from a reptile and put it into a amphibian, you will not get a life form. You just get a mass of cells and it'll die. Now, the writer of Jurassic Park, I'm trying to remember his name. He was a doctor. Crichton is his last name. But he describes in Jurassic Park how they splice in frog DNA, to make the dinosaur DNA work. Well, we now know that that's not going to work because the DNA from the dinosaur is different. It doesn't fit in a frog with a frog DNA, and it doesn't even work in a frog cell. So you take a frog zygote and you stick in DNA from a reptile, and it doesn't work. You can take DNA, for example. Now, cloning is where you take a different sheep, but it's a sheep. You take the brother sheep and you put it in this egg cell and you incubate it in the mother sheep, and out comes a sheep. But it's still a sheep, and the DNA fits. But there's more levels of information than we even know.
Yeah, that reminds me of something that Dr. Stephen C. Meyer explained, just talking about this seemingly non-functional or non-efficient information or structures in nature that as we truly continue to study them, continue to dive into the research of these structures and information, we usually find out that there actually is function to them, like you were talking about, like with junk DNA. So the reality is that even if there is something that we find that is truly non-functional or non-efficient, that can easily be explained, as you were talking about, as the degradation of nature as time goes on, the degradation of this information and function, because we're getting a copy of a copy of a copy of a copy of a copy. It's not upgrading, but it's degrading because over time, as copies continue to happen, it's inevitable that we're going to get less function, maybe degraded information. So that makes a lot of sense. The reality is, even when we find that, from a theistic perspective, it makes sense when we find that the non-functional stuff is dwarfed by this grand design we see everywhere else. In an atheistic world, it really should be the opposite. The vast majority, if not everything, should be non-functional, and function information should be the exception. Instead, we find ourselves in a world where there's this grand design, function, information out the kazoo, and then the exception is the non-functional stuff, the non-efficient stuff, which again can easily be explained by degradation over time because of natural law. So that makes a lot of sense.
So that's great. We're really concerned about the loss of information in the world because we don't want organisms to go extinct. We want to preserve them because once they go extinct, that information, unless we have a record of it and we can somehow recreate it, is lost forever. And a lot of organisms, even in my lifetime, have gone extinct. So there was a much more information in the past human beings observed than there is now. In the history of humanity, the information has been decreasing because we lost a lot of organisms and species that once existed. And that information is gone.
Wow, I have never thought about that before. That's such an interesting point that we have less information today on the planet than we did, say, a couple hundred years ago, a couple thousand years ago, and beyond. That's crazy to think about. Now, at this point, I want to talk about, obviously, I love this topic. I can see you love this topic. What's been a book that's really caught your interest? It's one of your favorite books on information theory as it relates to intelligent design. And what's that book that you would recommend to our audience? Say that they're just getting into this, they want to go learn more about information theory and its relation to intelligent design. What's the one book you'd say, okay, go read this book?
Okay, that's a good question. I would say the a the creation of life, a cybernetic approach to evolution would be a very good book. It's by A. Wilder, Wilder -Smith. And anything you can get by A.E. Wilder Smith is would be great. There's another book that has similar description in a little bit more, written a number of years later, called "The Natural Sciences Know Nothing of Evolution." But of course, the title doesn't seems more amenable. The Creation of Life: A Cybernetic Approach to Evolution. And cybernetic means the science of information.
What is it that you like specifically about those books? What makes you recommend these books over others? What do you love so much about them, and why would you recommend them to our listeners?
Well, he explained some of this stuff so well about how packed life is with information, and what information is and where it comes from. And he answers a lot of questions that people might have about this, like you've been asking and stuff. So I really like that about the book. He's got a lot of other interesting stuff in the book. I could go into some things. Being a polymer scientist, he had 3 PhDs in chemistry, different kinds of organic chemistry, and in several different branches of chemistry, 3 PhDs. I don't know anybody that got 3 PhDs in the sciences, but he did. And so there's other interesting stuff in the book, and he actually puts it in a way that you can understand.
Okay, here's my last question. What advice would you give to a new explorer into this field of study, someone who's going to continue asking these questions and start delving into the data, the research, what we know about the world and information specifically? What advice would you give to that person as they start on this just exciting search, delving into the rich world of information and complexity all around us?
Hmm. Well, look for things, and you mentioned, Michael Behe. There are others that you can look to understand this, and of course you're going to have a lot of references. If you start with A. Weller Smith's book, you're going to have other books that you can go to and look to. You can look up online. It's very interesting, actually. You can find A. Weller Smith debating Richard Dawkins and another atheist at Oxford in 1986. It's kind of funny. You can find a lot of things, right? If you know what if you're looking for it, right? So just search and search more information, and if you seek, you're going to find it. Now you got to cull through a lot of stuff because there will be a lot of people with emotional things and responses, but you want to cull through to find something that really can explain this well to you.
Very cool. I love that.
You can go to my website, by the way.
Yeah, where is that? How can they
It's
find
not a
that?
real fancy website. It's just got presentations that I've done, and it's called www.truthbehindlife.com.
You guys heard it, www.truthbehindlife.com. Definitely go check that out once you're finished watching here. Lots of great videos and blogs. I've already checked it out. You can find a lot of rich information on subjects just like this. So you'll definitely want to go check that out. It's a definitely very valuable resource. Well, friends, that was it. That was our discussion on information theory, intelligent design, and evolution. I hope you found it as interesting and just wondrous as I did. This is our guest, Dr. Perry Sherman. So thank you so much for joining me, and I will see you guys next time.
God bless.